Yes. Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, right?
Yes, sir.
Fine. So in the last, we had a demo session, right? So in that, I was just briefing you about PySpark. What is Apache Spark, why PySpark and need for it, Spark, Python, and Scala, and real-time usage of PySpark and PySpark job market. Right. So the Apache Spark was developed by Matai Zaharia in the AMP lab. It was open sourced in the year 2010. It was donated to Apache Software Foundation in the year 2013, right? And it is used for big data. So it was introduced in the year, right? It was open sourced in 2010, and it was donated to Apache Software Foundation in the year 2013. It was developed in the year 2009. It was open sourced in the year 2010. It was donated to Apache Software Foundation in the year 2013. Used for big data analysis and for processing and for computation, right? Yes. Defining Spark means it is an open source distributed execution framework, cluster computed with in-memory computing feature with parallel process style used for large scale data processing. Mainly you can see in-memory computation, right? In-memory computation, right? Computing, right? In-memory computing. In-memory computing means storage happening within the memory and processing is happening within the memory, right? In memory, everything, storage and processing, everything happening within the in memory, right? Parallel process style, parallel process style, right? Okay, cluster computed, parallel processed, in memory computed, distributed execution framework, right? Used for large scale data processing. Spark can be coded with Scala language. Scala, it can by default Spark built by using Scala, and Spark built by using Python. Spark can be coded with Scala. Spark can be coded with Python. Okay, Spark will be coded with Java and odd language. With all this multi-language support. Okay. So why PySpark is an Python API to use Spark, right? It's a lightning fast technology that is designed for fast computation, right? Yes, it's lightning fast technology which is designed for fast computing. So it's one of the demanding tool among the data engineers, right? Demanding tool among the data engineers to work with bigger data set. So here why we use for PySpark nut for distributed SQL, right? Like we have got components like Spark SQL, data frames concept, right? Where we make the data structured. Where we make the data structured, right? Yes. And performing some kind of querying on that kind of data. And we have got many data frame APIs available and we're converting to normal SQL statements and performing querying on it. And creating data pipelines. So Spark is a data flow language. So data flow means sequence collection of pipes. So each pipe at least some transformation, filtering, grouping, sorting, aggregation is going to happen, right? So the output of one will be the input to the next flow, right? The output of one flow will be the input to the next flow, right? Ingestion data into database, ML algorithms, machine learning. This Spark with Python, right? PySpark mostly like this used for ML machine learning things, right? And graph or data stream, graph algorithms and data stream, right? So PySpark is mostly used for these things. So we have got many PySpark packages like PySpark.sql, PySpark.streaming, PySpark.ml machine learning, PySpark.ml lib, right? Package, right? Spark. So as I said, everywhere we see like a large amount of data is generated both offline and online, right? So we see many hidden patterns in it, unknown corrections. We can see market trends and customer preferences and other business informations, right? So we need, it is necessary that we need to extract valuable information from it. So we require more efficient tool to perform these types of operations on the big data, right? So so already we have got many tools available, but they are not so appealing, right? So we go for scalable and flexible tools like PySpark, right? So we can gain some benefit from it. So the combination of Python and Spark, Python and Spark, combining Spark is an execution model implemented by using a language called Python. Both Spark with Python, we call it like PySpark, would be the very efficient for the world of big data. That's why Apache Spark community, it has came up with a tool called PySpark. It has came up with a tool called PySpark, that is Python API for Apache Spark. Python API for Apache Spark, right? Yes. Python and Scala, right? Yes. So difference between Python and Scala, which one can be mostly used? Most of the strengths will have by default Spark built by using Scala. So even today, like Python is mostly preferred because it has got many libraries towards this ML and graph algorithms, right? Yes. It is dynamic typed, means what value you are assigning, based on that the variable gets created. So a float variable gets created, integer and a list will be created, right? As you what you are assigning, based on that the variables getting created, we say like dynamic typed, and these are static typed, and has got a huge community, right? Huge number of libraries available for Python, 89,300 inbuilt modules available. Scala is smaller as compared with Python, and Python contains powerful libraries, right, for ML, graphs, and other things, right? And it is less as compared with Python. PySpark features, right, is in-memory computing, like in-memory computation, storage and processing happening within the memory level. Storage and processing happening within the memory level, right? Yes.
Sir, one question here. So if
Yes.
storage is happening in memory RAM level, so we need more RAM in
Dis-
computer.
Distributed RAM.
Okay.
For example, your file size, your RAM size is, assume each system RAM size is 8 GB. There are 10 systems. Total RAM capacity
80. Okay.
80 GB. Your file size is think 50 GB.
Mm-hmm.
50 GB is going to be divided into different parts, multiple partitions. Those partitions are distributed across multiple RAMs of multiple slaves. Means it is not going to be stored in a single system, right? Where you won't see the advantage of parallel processing, right?
Mm.
So your data object is going to be divided into partitions stored across multiple RAMs of multiple slaves and are processed parallelly.
Okay.
So what
Understood.
advantage you get is in-memory computation is one, parallel processing is one, right? And distributed. So yes. So because of this, Spark has got very high speed, right, as compared with the other technologies. Lazy evaluated. The data flow gets executed only when we perform an action. Lazy evolution means Spark is a data flow language. One flow output will be the input to the next flow. Again, the same thing. That output will be input to the next flow. So lazy evolution means it will be executed only when we perform an action. When we perform an action only, right? Fault tolerant. Multiple tasks executed by multiple slaves. If any one slave goes down, multiple tasks are executed by multiple slave systems, right? If any one system goes down, then the task of it need to be assigned to any of the other available slave. This process is called as fault tolerance. Yes, persistence means transformations can be reused, I said. Transformations can be reused, distributed, and parallel processing, right? Yes, these are the features. See, and real-time usage of PySpark. Real-time usage means yes, it is used in the commercial sector, right? Yes. So we say real-time processing. Real-time processing. We say real-time usage or real-time processing using Apache Spark. Immediately, then and there, right? Giving the results. Means if a fraud is happened, right? After 2 days, you are detecting that the fraud happened. But using PySpark, then and there we say like fraud happened, right? Okay. So here, if you see most of these banking sectors, financial sectors using Spark to retrieve various customer social media profile, right? And analyzing and gaining useful insights, which can help them in making the right decisions. Like even in credit risk assessments, targeted ads, and customer, right? Yes. Even in the fraud detection, it plays a vital role, widely used in ML tasks, machine learning tasks, right? Yes. So even in the healthcare also, right? Keeping in track of the all the previous medical reports data. So here, if you want the patient's records with the previous history of his medical history, and also predicting the patient which is probably to face that issue or the problem, right? Who has been discharged from the clinic. Also, even you can predict those things, right? We have got ML techniques implemented using this Python functionality, right? PySpark functionality. Entertainment industry also, even if you see many OTT platforms also using PySpark, right? Because the rate of speed of processing of PySpark is very high as compared with other technologies. With a very rate of speed, with a very high rate of speed, we can process. Even the industry is expecting very high speed processing, right? Even in the entertainment industry, right? We use like the OTT platform like Netflix uses Apache Spark for real-time processing and for personalized online movies or web series, right? I said right in case of this Netflix, nearly 450 billion events per day it processes, right? It processes nearly 450 billion events per day that are streamed on server side application, right? Yes. Even in the tourism industry, in e-commerce and the tourism industry, right? So even like the e-commerce sites like Amazon, Flipkart, even they are using this Apache Spark, PySpark, right? And even for this kind of recommendations, right? And for advertising, providing some offers or enhanced customer experience, right? To and optimizing the overall performance. Tourism industry, right? Even in the tourism industry, right? To provide advices to millions of travelers. Okay. So even I was just giving an example in the previous session, right? Yes. Taking 100 TB of 1024 columns, right? So to check the speed of various databases, right? Yahoo has taken a table of 100 TB consisting of 1024 columns, sorting based on 16 columns. What is it? Sorting based on 16 columns. What is the time taken by various databases? Okay. So the time taken by Oracle database, it has taken nearly 3.5 days to process this, right? And MySQL has taken nearly 6 days. Teradata has taken 4.5 hours, right? And Netija has just taken 3 hours. Netija has taken 3 hours. Hadoop has taken 3.4 minutes. Oracle 3.5 days, MySQL 6 days, Teradata 4.5 hours, Netezza has taken 3 hours. And finally, Hadoop. See, this Teradata and Netezza are kind of specialized databases used for data warehouse purpose. So they can handle huge data. That's why they take only hours of time, right? 4.5 or 3 hours. But finally, Hadoop has just taken 3.4 minutes to process. 3.4 minutes, right? Yes. So that is the speed of Hadoop, right? But PySpark, if you see, 100 times faster than Hadoop. It's 100 times faster than Hadoop, right? Yes. Talk like PySpark, mainly designed for batch applications. Batch applications means user non-interactive applications where user won't give the input. Credit card statement generations for millions of customers. Phone bill statement generation, right? For millions of customers, right? That is mobile bill. So in this way, where millions and trillions of records are involved, batch applications. Second, like iterative algorithms, right? Interactive queries. Interactive queries, right? And for streaming. Batch applications for iterative algorithms for interactive queries and for streaming. And real-time use case of PySpark is for commercial sector, healthcare. We have discussed. Okay. So you need to know something about these RTDs, right? Spark data objects. RDDs, right? Yes. Resilient, resilient distributed data set. This is resilient distributed data sets, right? Yes. What do we call as RDD? Nothing but Spark data objects. Spark data objects, right? Yes. Spark data objects are called as RTDs. Spark data objects are called as RTDs. RTDs are subdivided. Any Spark data object or RTDs are subdivided into partitions. Subdivided into partitions. These partitions are distributed. These partitions are distributed across multiple RAMs of multiple slaves. These partitions are distributed across multiple RAMs of multiple slave nodes and are processed parallelly, right? Yes. If you talk about this in RTD is programming style. RTD programming style, right? Yes. Data flow. RTD's programming style is data flow. Data flow is a sequence collection of pipes. Data flow is a sequence collection of pipes. What is a pipe? A pipe can be any data operation. A pipe can be any data operation, right? Any data operation. Such as loading data, transforming data. Yes, transforming data, filtering data, grouping data, merging data, etc. Right? All this data flow is a sequence collection of pipe. At each pipe, a pipe can be any data operation such as loading, transforming, filtering, grouping, merging, all this, right? Yes. Observe carefully in Spark. Data flow is executed. Data flow is executed in sequence. Data flow is executed in sequence. That is RTD by RTD. One after the another. In Spark, data flow is executed in sequence. That is RTD by RTD. One after the another with in-memory computation. With in-memory computation, right? And persistence feature, right? Yes. So observe this RTD is executed in sequence one by one. See, one RTD output will be the input to the next RTD, so that two RTDs cannot execute in parallel. Observe here, two RTDs cannot execute in parallel. One RTD output is the input to the next RTD. Two RTDs cannot execute in parallel, as one RTD output is the input to the next RTD, right? Yes. Okay. But if a RTD, observe here, but if a RTD has 30 partitions, if it is had 30 partitions, but in a RTD, but if a RTD has 30 partitions, then they can have, then they can execute in parallel. Observe this flow, right? Yes. If you want to understand these things, right? If a RTD has 30 partitions, then they can execute in parallel. Observe.
Is 30 the limit? Like
Example, R1 is an RTD. This RTD has got 30, it is divided into 30 partitions. P1, P2, P30. This 30%, 30 partitions loaded in 30 RAMs and are processed parallelly. The output will be collected and it will be given to the next RTD2. RTD2, the input will be the output of that previous one. Observe this flow, right? You will try to understand this RTD's importance and this The one thing what you need to understand is persistence, the concept of persistence, right? So here, if I see this, observe this flow R1, R2, R3, the flow is like this R4, R5. Here R6, R7. R1, R2, R3, R4, R5, R6, R7, R8, R9. So flow 1, what is, see, this is your flow 1. This is your flow 1. Flow 1. R1, see, observe R1, R2, R3, R4, R5. In flow 2, you observe R1, R2, R3, R6, R7. Three flows are like this. If you want to execute the first flow, to execute the first flow, flow 1, executing the flow 1. To execute the flow, we need to make some action. R5 dot action. R5 dot action. If you perform action on that R5, the entire flow executes from the root. R1, R2, R3, R1, R2, R3, R4, R5. When R2 is ready, see here, when this R1 ready, R2 ready, see R1 output is taken as input by R2. When R2 R2 partitions loaded and R2 processed, right? Then R2 will be removed from the RAM because all the RTDs cannot be accommodated by the RAM. And the current RTD processed and computed, previous one gets removed. R3 is ready and computed, R2 gets removed. R4, when R4 is ready, R3 gets removed. When R5 ready, means every time the previous RTD gets removed, right? Final, once the execution completed, R5 also gets removed from the RAM. Now no RTD in the RAM. No RTD in the RAM. Once the final output is collected, the final output will be collected, and what you see in that final RTD also gets removed. No RTD in RAM. If you are executing flow 2, flow 2 means what you will say R7 dot action, R7 dot action. When we perform action on the R7, the entire flow executes from the root, from R1, R2, R3, R6, R7. When okay, R1 gets loaded first into the RAM, all the 7 RTDs at a time won't be loaded into the RAM, right? One after the other, the partitions will be loaded. All the 7 RTDs cannot be accommodated. Already one RTD has got larger volume. So one R1 first loaded, then the output is taken as input by the next one. When RT is ready and computed, R1 gets removed. When R3 is ready and computed, R2 gets removed. Similarly, when R6 ready and completed, R3 gets removed. R7, R4. Once the total output is collected, R7 also removed. No RTD in the RAM. No RTD in the RAM. Okay. Flow 3. R8 dot collect. R9 dot collect. Sorry, R9 dot collect, right? Whenever I say R9 dot collect, from R1 to R2 to R3 to R6, R9. Similarly, here when R2 is loaded and computed, R1 partitions gets removed. When R3 is ready and computed, R2 gets removed. Similarly, this process continues until the entire flow executes. Final output of this R9 will be collected and no RTD in the. You can trigger the next flow to execute, right? So in this way, how this computation is going to happen? If you observe carefully, what is the thing commonly you are observing in all the flows? The first 3 steps are common in all the flows. R1, R2, R3 is common in all the flows, right? Yes. Right. In the above flow, in the above flow here, each time the flow is re-executing from the beginning. The flow is re-executing in the above flow here, each time the flow is re-executing, even though the first three steps are common. The flow is re-executing from the beginning. And so to avoid this, right, what we do? We need to identify the RTD whose output is commonly used by many different flows, and persist it. We need to identify whose output is commonly used by many different flows and persist it. Can you please, I want the sessions to be interactive. Can you please answer, right? Which RTD's output we can persist here? Whose output is commonly used here?
I think R3.
R3.
R3 output is commonly used by many flows, right? R3's output used by this first flow, second flow, third flow. If you know, this persist this means making the RTD available in the RAM only, so that it can provide output for all the 3 flows, for R4, R6 and R8. Okay, so I'll come back to this persist, but before that, and
Vijay, one doubt here. Can I ask?
yes.
See, you told that each RDD is divided into partitions and shared across number of flaps. So once these partitions will execute, how it will be again collected by that same RDD and given the output to the next? Can
So
you explain with the diagram?
see here, 1 second. In the already I showed you in the diagram, right? Yes. Mm,
The partitions.
on R1 RTD, R1 is an RTD data object. Data object means it has got some transformation applied on it. RTD means P1 partition, P2 partition, P3 partitions. On these three partitions, transformation applied. The output will be computed. The result what you get is nothing but R2. Observe. The result you get is nothing but another RTD R2.
But how it is identify that P1 and P2, P3 output will be the R1 output?
No. P1, P2, P3 will perform some transformation. Okay. So here, 1 second. For example, if you are performing some kind of filtering or transformations, you are going to apply some kind of transformations. So here, 1 second. P1, P2, P3. From P1 to P1, you may get all the data or only some specific data. From P2 to P2, from P3 to P3. If you perform filtering operations, only some data you may get. So this new P1, P2, P3. So here we call this as narrow transformation. Narrow transformation means from the same, there is no shuffling involved. There is no shuffling involved. If any filtering, if anything, any other operations, right? If from P1 to P2 data is going, from P1 to P3 data is going, right? It's shuffling involved. Then we call it as a wide transformation. So here, this output, whatever is there. See this P1, P2, P3, RTD is immutable. RTD is what? Immutable. We cannot modify or change it, but you can take its output. Output you will be taking it. R1 output you will be taking as input to R2. So here P1, P2, P3, you will have the number of records will be less than or equal to this P1 of this. Here also less than or equal to P2, less than or equal to P3. So this is what R2. R2 is a new RTD created from this. Understood now?
Sir, one question here.
Yes.
So in one of the notes we have written that RDDs cannot be processed parallelly.
RTDs cannot be processed parallel. Yes.
Correct? So
Yes.
because one output will be input for the other RDD. But in the same notes we mentioned, if it has example, we have taken 30 partitions, then it can be processed parallelly.
Yes.
If I take here, R1 has 30 partitions, R2 has some X partitions. If R2 is depending on R1, then also it cannot process, sir.
R1, see here, you mean R1, R2 can't execute parallelly?
I mean, that's what my understanding from the notes which we have written somewhere.
Yes. R1 first, okay, R1 partitions computes.
Yeah.
After that, you will get P1, P2, P3 as the result.
Correct.
See on the P1, transformation 1 applied. On P2, transformation 1 applied. On P3, transformation 1 applied. So here, whatever logic you are applying will be applied on each and every partitions separately. See, if our data object divided into 10 partitions, on 10 partitions, there were transformational business logic applied.
Okay.
The result you will be getting. Okay, you'll be getting some partitions again, P1, P2, or P3, some partitions you'll be getting, right? That is nothing but the R2. So R1, see, simply saying R1 dot R1 into R1 if you apply a
Yeah,
transformation
R1 T by R. Okay.
equal to R2. Means, okay, 1 second.
Sir, can you go back to the notes which we written, sir?
Yes. So let me make it clear, right?
Yeah.
R1 equal to first using the Spark context, if you load some text file, some file1 dot txt, a txt file you loaded it using Spark context, R1 is an RTD, first RTD created. Observe here. First RTD created. On this R1, you got some n number of records. On this R1 dot filter based on city equal to Pune. I want only Pune records. So whatever that output it is written from this is nothing but R2. R1 has got all cities data. R2 will
Correct.
have only one city's data. That is only Pune city. Next again on that R2, I doesn't want all the entire Pune's data. I
Correct.
want only department number 11, 12, 13, 14 is there. Department 11 marketing, department 12 sales, department 13, some different departments are there. Sales
So that would be
department,
R3.
marketing. R2 dot, again I'll filter. I doesn't want again this entire Pune records. Again, I want a department number equal to marketing department, MRKT, marketing department data only. So again,
Yep.
from that R2, again I'll filter. I'll get
R3.
R3. Means is a data flow from R1, the output is
Correct.
taken as input by R2. And for R2, the output is taken, you perform some, you will get some input to R3.
Input.
So here
Understood.
again, here R1 will have all the cities, R2 will have
Correct.
only Pune. Again, R3 won't have all the departments data, only particular department data. So
Correct.
it's a data flow, it's a data flow. Similarly, like R4, R5 means not only filter is one of the transformation. This way we have got many transformations available, mapping.
Understood, sir.
So in this way, so this entire flow won't execute automatically. It's lazy evaluated, like
Understood.
functions. If you define a function, until you make a call, it won't execute. Normal
Understood.
functions, right? Here also,
Yep.
until you make some kind of action on which one, generally we make action on the last RTD. R5 dot action. R5 dot action means what happens? One by one RTD gets loaded and finally
Yeah.
computed. But during this process, your RAM cannot accommodate all these RTDs. If all the 5 RTDs to get stored in the RAM, then RAM will be full. It won't, the next flow can't be executed because it won't allow it can't accommodate the next flow. So once the R2 computed, R1 removed. When R3 computed, R2 gets removed, right? When R4
Sir,
answer.
one more question related to this one.
Hmm.
So if for any reason if R2 gets fails, okay, so R2 R3 will not run because there is no data for R3 to run. So again R1 will run to get the data to R2
For
if
example,
R2 fails.
for example, R3. So generally, it R1, R2 won't fail. R1 has got some 10 partitions
Okay.
stored in 10 systems, 1, 2, 3, up to 10 systems. Slave 1, slave 2, slave 3, slave 10.
No, sir. I mean
No.
generally, if
You mean to say
due to
that
network, due to network.
your query is wrong.
Okay.
I'll correct it.
Okay, sir.
R1 is a data. Think that some 4 GB divided into 10 partitions. These 10 partitions, P1, P2, P3, P10, right?
Okay.
10 partitions stored on 10 slaves.
Understood, sir.
This slave 3, suddenly as they are machines, slave 3 is down. System 3.
Yeah.
Means P3 data lost.
Okay. So it will pick from some other slave.
P3 data is lost.
Yeah.
So in such case, what it will do?
It will pick from P1 or P2 or P10.
No. It cannot take. In
Oh.
slave 2, only P2 data is available.
Okay, okay, okay,
In slave 3, P3 is there. All 10
okay.
slaves storing 10 different
Correct. Okay,
partitions.
understood. Understood now. Yeah.
So in such case, what happens is, okay, think this is what this is all these 10 partitions belongs to R3. All these 10
Correct.
partitions belongs to R3, assume.
Okay.
R3 still it is not computed, right? Still not executed,
Correct.
right?
Correct.
Observe here, lot of things you need to understand here internally. I'll give you many examples.
Yeah.
R3 is not computed, right?
Correct.
R3 is not computed means R2 available in the RAM or not available?
Available.
R2 available, right, in the RAM?
Yeah. Yeah.
I said when R3 computed and finished ready, R2 gets removed, I said. So
Correct.
now when R3 any partition is down or any system is down, anything is failure, R2 still available in the RAM, right?
Yes.
So,
Yes.
so what it will do is simply R3, what it does, simply it will deallocate all this. Again, it will take output from R2 again in 10 systems, it will store it, other than the system which is down.
Okay.
Understand this? When
Yeah.
any system is down means some number, n number of records, some lakhs of records are lost, P3. So some data is
Okay.
missing means you cannot further go for the processing. So what it will do immediately, what all the partitions they will be deallocated again.
Sir,
It will take the output from R2 and again it will allocate 10 slaves other than the slave which is down. Right? Yes.
No. One more,
sir,
sir. One
can
more,
I
sir.
ask one question?
Yes. So actually this is fault tolerance mechanism, right? With multiple cases we'll be discussing about this. This is fault tolerance we call if any particular thing is down. Yes, yes. Any query you asked, right? You were asking some query. Yes.
Sir, what is the cost of this training of PySpark?
By Spark it is 8K, 8,000.
Okay, sir.
So
Okay. Sir,
okay.
sir, one more
one
question
question.
actually.
Yes.
Yeah, one question. Sir, if suppose if the data we have around 100 GB
Yes.
and the RAM of all the nodes is around 50 GB, suppose to, can it be possible? Can the Spark execute the data which is higher than the RAM?
Overhead. You will get
Yeah.
you will get overhead error.
So always the RAM should be higher than the execution data, right?
So here your total distributed RAM is less, and your but if it is less by some, okay, for example, we have got some persistent options are available. Options means like memory only, memory underscore only option, disk only, memory and disk only, memory and disk only. We have got some options like this: memory only. If you use memory only, use disk only, or use memory and disk only. We got these options available. Generally memory only will be that option, but in such case if you see memory and disk only, right, if unable to fit in your memory RAM,
Okay.
use your disk. Means instead of the job getting failed, instead of not availability of the memory, right, use disk. Understanding?
So if it is exceeded, then it will use the disk.
So here if you give that option, right, memory and disk options, memory and disk only. But if you are given only that memory only option, right, if you have given only the memory only option, then it will be failed if because of this less memory, right, because of less memory,
Yeah.
right? So in
But
such case one thing is based upon your incoming data, based on your data, right, you need to just the cluster need to be formed, right, with n number of systems in n node cluster, in which the RAM need to be distributed, whatever the RAM you are, right, you need to allocate it accordingly. But still, if it is if you are just your RAM is your totally 10 GB RAM, but there's something, there are thing available here, there is some available, the things available, right? So either you want to totally go for disk, You want to go for memory, or I want to make use the advantage of memory. As I got memory, I want to use memory if available. Otherwise, go to disk. This memory and disk means, for example, the memory is busy executing other flow. Assume the memory or RAM is busy executing the other RTD's other flow. As of now, it is busy, but after some time, it may become free once the execution completed. In such case, up to that time, you just execute it in the disk. Later, once it is free, again shift it to the memory and execute, right? That is what happens in this. If you directly give disk only, everything happens in the disk only, right? So I said Spark is 10 times fast, 10 times faster, 10 times faster, right? As compared with Hadoop in the disk level. In the memory level, 100 times faster. In the memory level, 100 times faster. In the case of memory, in the memory level, right? In disk level, it is 10 times faster, right? So understood, right?
Still, I have doubt on partitions. We just suppose this R1 has 3 partitions and it is assigned to 3 slaves. Okay, and the computation is done on the partitions. But how this each partition output is, will it internally merging as a single output for R2? How it is taken as a single output from the 3 partitions?
See, for example, okay, it doesn't mean that all the RTDs should have the same number of partitions. Observe here, it doesn't mean that. 1 second. R1, is it mandatory that all the RTDs will have the same number of partitions? No. R1 has got P1, P2, P3. P4. Okay. Here, males and females data available, male employees and female employees, male and female employees, male and female employees, male and female employees. Partition nothing but a block, 128 MB by default. B2 block, 128 MB. B3 block, 128 MB. Fixed size. B4 means it, okay, the last one, it won't have something like 80 MB, only some less number. Okay, now blocks means they will have fixed size. So here male females, here if you think 80% males, only 20% females. Here 90% males, 10% females. Here totally 95% males, only 5% females. Here 75% males and only 25% females. Now my R2 is what? Only females required. Only females. Only females means how many partitions you will get? 4 you will get, or 1? Here 20, 10, 5, 25.
I think one partition.
One partition. Only one partition you will be getting.
Yeah, but my question here is how it is collecting from partition 1, partition 2, partition 4. Will it apply merging technology or something?
Yes, it will just take only those data. So we are giving filtering condition, right? Filtering condition you are giving only that female data, male gender equal to F. Only those data will be taken as, will be stored in this. That is nothing but R2. So here it will collect only those data from each partition. So P1, the filtering operation, transformation 1. P2, the filtering on transformation. P3 on the transformation 1. This transformation 1. Internally, it computes. All this will happen parallelly, executes parallelly in system 1, system 2, system 3, system 4. After that, all that outputs will be collected into a single machine. It can be a same machine or it can be a different machine, right? Say that S1. All the data will be collected into a single partition. So everything is a cluster, right? Nodes connected in network.
Yes, yes.
It is everything connected in network. So what do you mean by cluster? Group of nodes connected in a network, 40 node cluster or 80 node cluster. So everything will be collected into one. That is one slave one. Now R2 has got only the one partition. It doesn't mean that all the arteries will have the same number of partitions. It depends upon your transformation. So this we say shuffling occurring here, shuffling of the data from 4 to 1. If shuffling, no shuffling, again we have got a transformations there. Narrow and wide transformation. Narrow means no shuffling. Wide means shuffling occurs. Means between the partitions. Between the partitions, data will be moving here and there. If P1 to P1 as it is, P2 to P2 as it is, P3 to P3, and P4 to P4. That we call it as narrow transformation. No shuffling occurred. Same P1 to P1, P2 to P2. But here, when P1 to P3, when P1 to P4, P2 to P3, if the shuffling happens, we call it as wide trans. So here, everything will be collected into single slave as they are connected in a network. R2. Yes.
Okay, okay. It is not collected by R1, the outputs, right? It will directly collected by R2.
R2. See,
Okay.
RTD is immutable.
Yes, yes, yes.
We cannot modify it or we cannot.
Yes.
So it
Yes,
cannot
sir.
be changed. Yes.
Okay. Thank you.
Sir, so based on the number of nodes, the number of partitions will be decided.
We can control the number of partitions in Spark. In Hadoop,
Sir.
it cannot be controlled, but
Okay.
number of partitions,
Okay.
while loading the file, you will be loading the file name file1.txt, file1.txt. Beside that, we'll be providing the partitions. How many you want? 10 or 5 or 6. Means it will be loaded into
So
10.
it will be decided by us, user only.
So
The number of
while
partitions.
means we can load data into multiple partitions we can specify while loading, right?
Sir, if the number of nodes are 10 and the number of partitions are 20, will it be executed?
Yes, executed.
Okay, first 10 will be executed parallel, and then next set of 10 will be executed again.
See, one second. Why 10 systems? In one system also you can execute.
Sorry, sir, I did not get you.
You are saying 10 systems, right? In one system also you can execute, I'm saying.
All the partitions.
So yeah, all the partitions. But you want one thing, what you won't get is parallel processing.
Parallel processing, right.
See here, one thing, P1 is there, P2 is there, P3 is there, P4 is there, P5 is there. 5 systems are there, S2, S3, S4, S5. Full parallel processing, you will get it. Full parallel processing. High speed you can get by because P1, P2. All the 5 will be executed parallelly by 5 systems. As you said, 5 are there. P1, P2, P3, P4, P5. 5 are there. But only 3 systems are there. Slave 1, slave 2, slave 3. Only 3 systems. System 1, system 2, system 3.
Okay.
P1, for example, P1, P3 here. P2, P4 here, P5 here. How the partition stored like this?
Okay.
For example, what happens here when P1 is executing here P2 will be executing. Here P5 will be executing parallelly. Observe here P1 executing, P2, P5 executing. Here P3 will be in waiting state. Here P4 will be in the waiting state. Means here first round 3 partitions executed. Again in second round 2 partitions executed. Means here if it is taking 1 hour time, here how much time taken?
2 hours.
2 hours it will take. For example, here not 5 partitions, 13 partitions are there. Otherwise, not 12 partitions are there. So what happens? 3, 3, 3. First round, 1 hour it takes. Sorry. P1, 1, 1, 1. So system 1, system 2, system 3. Totally, how many are there? 12 partitions.
12 partitions. 4
It
hours.
should execute P1, P2, P3, P4. Assume it should execute P5, P6, P7, P8 is stored in this. P9, P10, P11, P12. How many hours taken? How many? 4 hours taken. Means what is your observation here? More slaves are there, more speed,
Less time.
more parallelism. If only
Yes.
one, if for example 3 slaves are there here, assume only one slave is there. What is the time taken for 12 hours? 12 hours. But if you've got 12 slaves available, only 1 hour. Okay, so that is what your data.
Sir, one more thing. Previously you mentioned that based on the options we give, memory level or disk level, memory and disk level, there were 3 options, right? So these options will be chosen by the user.
Yes, yes.
Okay. Okay, we can mention. Okay,
So
what kind of
yes,
operation.
yes, yes.
So if we have large amount of data and the size of the RAM, I mean size of the systems is smaller, then we can.
If you are able to account, the only thing is Spark. The companies which can afford Spark means you need to afford for huge RAMs, expensive. The
Right.
main thing is Spark will be expensive. The only thing is you need to accommodate huge RAMs. So based upon your data, you need to maintain that much RAM capacity, right?
Right, right.
If you want, still you can keep on increasing the slaves systems.
Yes.
So you keep on. So generally this Spark will run right this within the cluster, right? So you need to keep on adding the slaves depending upon your data value, right? So understood, right? So
Yes, sir. Got it. Thank you.
Yeah. So this is what. 1 second. So more discussion I'll be discussing that. This is the course content I'll be discussing in brief, right? PySpark need for Spark, need for features, web Spark sessions, parallelizing, broadcast variables, and PySpark RTD computations, persistence options, core computations, RTD computations, groupings and aggregations, various actions and transformations, inbuilt actions and transformations are there. Spark SQL data frames, right? Spark data frames API, data frames, right? Yes, PySpark, how to create data frames from different things, right? From row class, from struct field, from column class, select, collect with column renamed, right? Column where filter, drop, group by, join. All these different data frame APIs I'll be discussing, right? Union by name, flat map, for each, simple, fill, all this, right? And PySpark SQL functions are there, aggregated functions, and this different types of functions like lit function, when expressions, array contains, right? Different types of Spark SQL functions in brief I'll be discussing. And Spark external sources, from working with pure SQL statements, I want to perform some querying. So like Spark Hive integration, working with CSV, JSON files, narrow and wide transformations, adding columns, right? All this. And local mode and cluster mode, like deployment modes and stages and tasks, drivers and executors, and how the Spark applications, pipelines, deploying and performance tuning, right? These things. Yes. So everything in brief, I'll be discussing about this. So takes like nearly 10 weekends for this.
So
Fine.
10 weekends from from today, or
Yes.
already 1 weekend completed?
From today.
So one question: if I know Apache Spark, is it easy to understand PySpark?
Yeah, it will be easier to understand, right?
Okay, so I mean, if I know Apache Spark, I mean, without knowing Python language, um, I mean,
Python means we are not developing a web application or web application, right? That much of Python we won't be using, right?
okay,
Basic Python will be used. We are not
basic.
creating, it's not for web applications. Spark or Hadoop is not for creating any web applications or interactive or client server applications, right? It's for batch applications. We won't use that much of Python required, right? Only basic Python. It's not a great thing, like basic Python. What is it? You need to know the basics. What is
Yeah.
an list, collection, tuple, set,
Yeah.
defining variables. That I'll discuss for before I go with the practicals. I'll be just giving you the entire things, right? How we do.
Yeah.
That's even
Sir, you
Python is not a complicated the thing which can even you can update by yourself also, right? Yes.
Sir, you're taking other class also, right? Big data, where you are covering Apache Spark also there.
Yes.
Okay. So if I have that knowledge, I can understand this. I no
Spark.
need to attend this class.
See one thing, Spark will be same. Spark execution model, right? So, but
Yeah.
implementation in Python, implementation in Scala, right? The only the language is going to differ. Means I can implement this. For example, machine learning is there. Or if you talk about not machine learning, if here Spark implementation language is Python, it can be implemented in Scala. It can be implemented in Java also.
Okay. Okay.
So
Okay.
the understanding here, you can implement in different language. For example, you will write a program in C language. The same thing you can write in Java. The same thing you can write in Python also, right?
Correct. Sir,
Any C program you can write in Java or you can write in Python in the same way, Spark. But there are some special functionalities, right, available in PySpark. PySpark has
okay.
got some features available, right? So there is Python APIs available. Okay,
Sir,
so
I am opting for big data course, so no need to attend this course, right?
that there also, if you go for big data, right, Hadoop and Spark, there also
Yeah.
you'll be getting both Hadoop and Spark knowledge, but with Scala implementation, you'll get in
Correct. Correct.
Python
If
implementation.
I learn that tomorrow with Python basics, I can understand this one, right?
Yes.
Because I am already learning Spark there with
Okay,
Scala.
okay, fine.
So no need to go for two courses, right, sir?
Yes.
Can you share the course details? I mean, this list, this content, this one in the
Okay.
chat panel. You will download the code. This.
What then? Yes.
Can you share this?
Okay, you'll be getting in your mails, right? Everyone, you'll be getting these things in your mail IDs. Okay. Whatever mail IDs, right? If you will be getting to your mail IDs.
Every day, the number of hours will be
So it will be for 2 hours on Saturday, 2 hours on Sunday, right? So it will be from 4:30 to 6:30 and 4:30 to 6:30 on Saturday and Sunday.
so it will be for 40 hours content.
Yes.
Okay. Another thing is I'm using PySpark in Azure notebook. I'm running this Spark pool, wherein I have to use that PySpark for data cleaning. And I'm using this df3.with column and df3.select, df3.select expr, these functions.
Yes, yes.
Are we going to include such data cleaning?
Yes, yes. We have got many APIs available. I'll be discussing one by one, all in brief. Right?
And is there an open source available which I can refer for such data cleaning activities?
Yes, yes. I'll be providing all those. So even for your people to execute, right? If you want to do the practical part, different ways I'll be showing you, right? How to execute and how to run these things, right? Yes. Okay. So yeah. So any other queries? We will just continue the session tomorrow, right? Same time, but tomorrow, yes, yes. One second. And tomorrow there will be the link will be changing, right? You need to get enrolled, you need to get registered, right? Already last weekend you had, this weekend, right? But tomorrow we cannot keep going with this, so we'll be entering into this course, right? Tomorrow onwards we'll be just entering into this and we'll be doing with the fundamentals of this RTD computations, different RTD APIs, right? Other things. So yes.
Sir, I have done the payment. Will I get the link through my mail ID?
Yes. Everyone, anyone, those who are done, right? You don't forget to share your details, right? The screenshot of the payment. Please
Yes,
be
sir.
in mute.
Already done, and the team has added me to the
Yes. Today,
Drive.
yes.
Google Drive.
Tomorrow morning you'll be getting the link, right, to your mail. They'll be forwarding to your mail IDs. Who all the
Actually, I thought that from today itself I'll be getting. So I did not.
No,
I did
today
not.
also, today also it was given, right? Tomorrow the link will be changing. Only those who got registered and enrolled.
Okay.
Sir,
So you'll be getting this link you will be getting, and from tomorrow daily in your Google Drive you can check for the videos. Please be in mute.
sir,
Right?
sir,
If
can
you
I
have-
ask?
Yes, please, 1 second. Give me a second. Right. Okay. Tomorrow, from tomorrow, right? The link, whatever link you are following. So a Google Drive, check in your Google Drive for the videos, right? Daily videos will be getting to your Google Drive, and notes you will be getting to your mail IDs. I'll be forwarding topic wise. Whenever that every week I'll be forwarding the notes to your mail IDs, what all we are discussing. And a WhatsApp group also will be created for this technical discussion, right? Three things: videos you will be getting, notes you will be getting to your mail IDs, videos to your Google Drive, and a WhatsApp link for any other discussion, technical discussion, other things, right? Fine. Yes.
Sir, when the videos will be shared, sir? Once the class is done?
Tomorrow a WhatsApp group will be created. From tomorrow itself, it will start. Videos will be shared tomorrow from your Google Drives. And if
WhatsApp
any,
group will be
yes.
created on the class itself.
Tomorrow at the end of the class, I'll paste a link, WhatsApp group link in the chat panel. You can click it and get added right tomorrow itself. And from tomorrow in Google Drive, you can just, if anyone not getting the videos, you can that online team details will be provided. Online team details will be provided. You can contact them if you're not getting the videos, right? Still, if they are right, still you can message me in the group. Still, if any, if they are not responding, like right.
Yes, sir. Can I ask?
Yes, go ahead.
Sir, I want to ask that PySpark is more in demand or Scala Spark?
Yes, PySpark today mostly used even in ML, right? Machine learning, right? Machine
Yes, sir.
learning tasks. So even I won't say like both are equally used. I'm not saying, but these days PySpark mostly used. It has got more demand than Scala. Previously, if you see in 2016, 17, 18, 19, only Scala was used more. At that time, PySpark was less used, right? But from 2020 onwards or 20, you see like the usage of PySpark has increased. Even in ML techniques, in machine learning techniques, algorithms can be implemented, right? By using PySpark, right?
But sir, somebody told me that
yes,
PySpark is slower than Scala Spark, and as Spark is written in Scala, that's why Scala Spark is more in demand.
Yes, it's correct only, right? Scala is faster than Python, right? Scala is faster than Python. By default, Spark built by using Scala only, right? Yes. Whatever you heard is correct only. Python is slower as compared to, even if you see comparison of Java, Scala and Python, Java is faster among all, next to Scala and this, but Scala by default, what we say, Spark built by using Scala language, and the Python is slower as compared to the other two, right? But only thing, the advantage why we use PySpark or Spark with Python is, so we have got some libraries, special libraries available in Python, which can be used for machine learning, right? If you are going for machine learning kinds of activities where your application involves those things, we go for PySpark.
Sir, I want to go in the field of big data and in the big data engineering.
Yes, big data engineering means you need to have the knowledge on Spark. Implementing on which language, that is up to you, but Spark is an execution model. What the APIs remain same, data frames, RTDs in both the language, but only thing is the implementation is going to differ. And apart from this, Python has got some APIs available for machine learning, and but Scala also has got APIs for machine learning, right? It can also perform this for streaming activities, for all those things. Scala also preferred. I'm not saying Scala is not used. Scala also mostly used, right? I can say like Scala, if I can say now, as per that 60 and 40, I'm saying Scala used 60 and PySpark used 40% in the industry. I'm not saying that you need to join this PySpark course, so that I'm not saying that you have to join with this PySpark. So I'm saying I'm not degrading Scala here. Scala is used more only by default. Scala is a language which can be used only for Spark, right? It is a native language of Spark. It is built for only Spark, right? No other environment using Scala except Spark, right? So by default, Spark built a total APIs, whatever we see, right? Spark APIs are everything built by using Scala. And
Sir, if I will learn PySpark and Python, and I want to become a big data engineer, then is it sufficient, or should I learn Spark also?
So if you go for, okay, even in the data science, right? Even a typical data scientist, right? It depend on this data engineer, right? For all these kinds of activities, what we do there. If a data scientist, mostly like Python only preferred there for this kind of task, right? They won't go for Scala language, right? So okay, and Scala means specifically for there are some like big data engineering, right? If you go for data engineering kinds of tasks, where only they'll ask for Scala, right? You can go for it. So I'm not saying both are used 50-50%. I'm saying not like as you need to join this course. I'm not saying that you should only PySpark only used more. Not like both are used. Yes, it depends.
Thank you, sir.
Okay, fine.
Yes, sir.
Sir, I have one more note here, and here Dinesh here. Sir, can you provide any questions for interview preparation on PySpark? And how to prepare and how to answer, which type of questions they will ask?
Yes, I can.
Sir, yeah, in this course, you will gonna to cover HBase and Hive also, or only PySpark only?
PySpark, but I can provide you the basic videos of Hive, right? Hive, how happens, because we are discussing Spark and Hive integration also there. How PySpark integrated with Hive. So for that understanding, I will be providing some videos of Hive, right? Basic videos, some 4-5 videos of Hive, not all those, right? So I can provide it.
Sir, I can same note, sir. For data engineering, which one is better, sir? Whether Scala is Spark with Scala or PySpark is better?
See, 1 second. For data engineering, okay, you need to have the entire knowledge of Hadoop and Spark. You need to have the entire knowledge, means Hive should be there, Scoop knowledge should be there, right? See, basics of Hadoop's required, Spark also required. And even if you want tomorrow, if you want immediately you want to work with, so even if you see today, like the job opportunities for PySpark, means people with the knowledge of PySpark are very less, right? So so means the jobs are more for PySpark, means I'm not saying for Scala, but data engineering. And even PySpark is one of the hottest hot cake in the market, right? Very few people got updated with this PySpark, right? At this point of time, that's why people rushing towards PySpark, and even implementations also going right using PySpark. So I won't say that is your wish, whether you go for Scala. I'm not degrading any of this. Both are used equally in that as of now. But previously, totally Scala only used up to like before 3 years, right? Up to 2019, Scala is used most. But now PySpark, Spark with Python also used. So I already said the differentiations between Python and Scala, right? So both has got advantages, both have got some disadvantages. Both, I won't say that all this. Okay, fine. As you said, right? Scala is faster as compared with Python. So
what is the duration of this course?
Duration of this course will be 10 weekends, right? 2.5 months.
Okay, sir.
Okay, fine. Yes. So still any other queries, right? Any other?
Sir, in this course you gonna cover Hadoop or only Spark?
So that knowledge required for some of that, like some HDFS, some basic Hive, and for Scoop, right? I'll be providing the basic videos of it, right? Scoop videos, basic Hive videos, and basic HDFS videos.
Yeah, those videos are enough to clear the interview.
I'll be providing it, right, to understand these concepts.
Okay. Thank you, sir.
Okay, to enter this PySpark.
Okay. Thank you, sir.
Okay, so I'm stopping here. We'll continue tomorrow, right? More discussion on this. And as I said, tomorrow the link will be changing. And okay, fine. Anything Spark with Scala or Spark is the execution model you are implementing in different language like Scala or Python, right? Okay. See tomorrow same time at 4:30, right? Yes. Okay, fine. Thank you all for your time. Thank you. Yes.
Sir, one more question.
Yes, go ahead.
Sir, actually, you told prerequisite videos required for HD. I mean, Hadoop and Hive.
Yes.
Yeah, can you share for tomorrow class before tomorrow class so that we can?
No. Once you got enrolled, right? I'll be just keeping.
We already enrolled. Some of the people enrolled.
Tomorrow you'll be getting those videos, right? Tomorrow evening will be provided. Means next week totally you can go through that before we go to the next session of next Saturday, right? Fine.
Okay.
So what all the things, right? The notes or videos or those how to basic those videos, everything will be forwarded once you got enrolled, right? Yes. So the separate Google Drive will be created that will be shared to all those enrolled students, right? Yes. Fine. Yeah. So I'm stopping here. Yeah. Any other queries, right? You can ask. Yeah.
Sir,
Clear notes will
for
be
practicing, which software we gonna use, sir?
Yeah, I'll be demonstrating those about the software also, right?
Okay.
That the software also I'll be forwarding to your Google Drive.
Okay, sir.
Okay. Fine. Okay. Yes.
Okay.
So I'm stopping here. Yeah. Yeah. Good evening, all. So myself, Vijay, I hold like 15 plus years of experience, right? Which includes nearly 8 plus years of experience in big data environment like Hadoop and Spark. So as part of today's demo, just I'm going to cover the following topics. But before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yes, sir. We can able to hear and I can able to see.
So, okay. So first, what is Apache Spark? Why PySpark? Need for PySpark. So most of them have got the query, right? Yes. Why we need to go with PySpark, Spark with Python implementation or Spark with Scala implementation, right? Like, so whenever I say like Spark versus PySpark, so Spark means by default it uses Scala language, and PySpark like Spark with Python implementation. Spark and PySpark, right? Spark with Scala. Otherwise, like you can say like Spark Python and Scala, right? Yes. PySpark features a real-time usage of PySpark. Yes. PySpark job market, right? Yes. Okay. So what is Apache Spark? Why PySpark? Need for PySpark, Spark Python versus Scala, and PySpark features, real-time usage of PySpark, and PySpark job market, right? Yes. So what is Apache Spark? Apache Spark, right? I can say it is a open source distributed cluster computing, right? Apache Spark is a open source distributed cluster computing framework introduced by Apache Software Foundation. Open source distributed parallel processed cluster computing framework which was introduced by Apache Software Foundation. So I can say it is a Apache Spark. This Apache Spark is a general engine for big data analysis, right? It is a general engine for big data analysis, processing, and computation, right? So this mainly used for, right, for data analysis, big data analysis, right? Processing and computation. So, okay, more on this I'll be discussing that, but why PySpark? Why PySpark? Okay, PySpark, I can say it's a Python API to use Spark. Python API to use Spark. Spark, I was saying that it's open source cluster computing, which is used for big data solution. So I can say PySpark is a lightning fast technology, which is designed for fast computation. PySpark is the very demanding tool among the data engineers, right? To work with bigger data sets. If you want to work with bigger data sets, right? So yes, if I say why PySpark and PySpark used for right, just observe it is used for distributed SQL, for running distributed SQL, right? Creating data pipelines, right? Yes. Ingesting data into database. For ML algorithms. For graphs and for graph or data streams, right? So it's used for distributed SQL, for creating data pipelines, ingesting data into database. Mostly, like as you see the PySpark major, you see in ML algorithms and graphs or data streams. So you are saying like, what is the need for PySpark? What is the
distributed SQL
need for PySpark? So here, if we talk about normal SQL, and here if you see Spark SQL, right? We got the concept of data frames concept available. We have got here data frames. See, huge data is there. The huge data, just you are going to process it, and you are going to make it like a structured format and create a data frame, right? Your data is distributed across multiple systems, right? Multiple systems. See, if the main advantage of Spark, see, as compared with other technologies, right? Very high speed processing, right? So your data is going to get distributed across multiple systems and are processed parallelly, right? So here your data is getting stored not within the disk level, memory level, RAM level. That's why we say in-memory computation. Spark is a in-memory computation technology, right? Because data getting stored within the memory level, data getting processed within the memory level, a bigger data sets, bigger data object divided into multiple parts, partitions we say, and stored across multiple RAMs of multiple slaves and are processed parallelly. So here we are going to create, after that we are making the data structured, creating data frames, we have got many data frame APIs. Later we can create the data frame register like temp tables and perform pure SQL kind of querying, right? So bigger data objects, if you want to query, right, which are got distributed across multiple machines, creating data frames and performing querying, right? So this kind of distributed things you can see within this means querying, this kind of querying you can see in this PySpark. And Spark is a data flow language. It's a data flow. Spark is a data flow. Data flow means you can see pipes, means it's a collection of pipes. Means you got the output of one will be the input to the next one. The output of one will be the input to the next one. Data flow is nothing but the first, that output of one will be the input to the next one, next pipe. So creating data pipelines, ingesting data to database, ML algorithms, and for data graphs or data streams. And need for PySpark here. Need for PySpark. So if you see today, large amount of data is getting generated both in offline and online, right? You see large amount of data generating offline and through online. So these data contain hidden patterns. They contain hidden patterns, unknown corrections, market trends, customer preferences, and other useful business information. It is necessary, right, to extract valuable information from the raw data, right? So we require more efficient tools to perform different types of operations on this huge data or this big data, right? So there are various tools already. We have got various tools available. I'm not saying that we doesn't have tools, but there are various tools to perform these multiple tasks on the huge data sets. But these tools are not so appealing. So it is required that we needed some scalable and flexible tools. We need some scalable and flexible tools to crack this big data and gain benefit from it, right? So PySpark is such a kind, right? So for this, what we do, combination of Python and Spark will be the very efficient for the world of big data, right? So I'm combining both. We are combining Python and Spark, where Spark is the execution model, Python is the language combinedly, right? So it's efficient for the world of big data. That's why Apache software community, right? Apache software foundation or community, right? Yes, it came up with Apache Spark. So it's a technology, right, for very high speed processing. Came up with a tool called PySpark. That is Python API for using Spark. Okay. So most of them have got queries, right? Whether to go for Spark with the Scala or Spark with Python, right? So both has got the equal demand in the market, right? Depending upon the requirements, right? But if you see that Spark can be coded, Spark can be implemented by using 4 languages, not only Python and Scala, right? Python, Scala, Java, and R language. Spark can be coded with Python, Scala, Java, and R language, but mostly used ones are Python and Scala. By default, Spark built using Scala. Spark built by using Scala. Scala is the native language of Spark, right? Spark, but these days, if you see, even Python is mostly used or preferred, right? Where Python is used as a language, where Python has got huge libraries, many libraries for different mod. It has got different modules for different environments, right? Especially for machine learning, or if you see for graphs, not only for SQL kinds of queries also, right? Even we have got Python has got some modules like pandas modules, right? So just if you see the difference between Python and Scala, just observe this. See Python and Scala, right? Yes. Python, Scala. Python is dynamic typed. Dynamic typed. Scala is static typed. Dynamic typed means here in, if you say x equal to 10, based upon what value you are assigning, the variable x is going to get created dynamically. Here we don't need to say like int x or float. Okay, in this way x equal to 10 or float y equal to 4.5, right? Here no need to say like based upon the value, what value you are assigning. Based on the value assigned, the variable x is going to get created dynamically. Y equal to 4.5 means float value, right? A float value assigned to y. What value you are assigning to x, what value you are assigning to y, based on the values assigned, the variables are created dynamically here in Python. So but Scala is static type. Okay, but so Python is a huge community, right? Python it has a huge community. It has smaller community, right, as compared with Python. So Python has got powerful libraries. Python contains powerful libraries. Powerful libraries for machine learning, for ML, machine learning, for graph algorithms. Etc. Right? Yes. Scala also contains, Scala also has got libraries. Scala also has got powerful libraries, but as compared to Python, right, little less compared to Python. Less as compared with Python, as compared with Python. So nearly 89,300 inbuilt features, a library, inbuilt modules Python has got for different domains, right? But less as compared with Python. The mainly thing is powerful libraries for machine learning. See, if you want to go for any machine learning kinds of activities, better go for Python. That is Spark with Python, right? Yes. PySpark features. PySpark features, right? Yes. First, the main feature what we see in memory computation. In memory computation. In memory computation, because of which it has got a very high speed, right? So here your data object, I said your data object is going to be divided into multiple partitions. Partitions are distributed across multiple systems into multiple RAMs of multiple systems and are processed parallelly, right? Yes. In memory computation, this even you won't see in Hadoop. Yes. Second, lazy evaluated or lazy evaluation we see, right? Lazy evaluation we say. Active evaluation or lazy evaluation, right? So which is better means lazy evaluation only, right? So on demand we can execute, right? On demand, right? Executing that, nothing but lazy evaluation means. So whenever required, you can just execute it, just like a function call, right? So whenever function, you will define function, whenever required, you will be calling it, right? At what time or how many times you want. So when required and how many times you want, you make a call. In the same way, lazy evaluated means you will define the flow, you will define the data flow. When you perform some kind of action, only your data flow executes, otherwise it won't execute. Lazy evaluation nothing but whenever you define the data flow, Whenever you make some kind of action, whenever you trigger an action, then only your data flow gets executed. Until then, it won't execute. Yes. Lazy active evaluation means immediately when defining execution. Whenever you define, immediately executing is nothing but active evaluation. But here, lazy evaluation means until you perform action, it's not going to get executed. Fault tolerance. Fault tolerance, it has got powerful fault tolerance model, right? You have got fault tolerant. So I was just saying that, just observe this. Your data object divided into smaller partitions. It is divided into smaller partitions and stored across multiple systems that are processed parallelly. So your data object, okay, think that here 10 lakh records, here 10 lakh records, here 10 lakh records, here 10 lakh. So they are processed parallelly. Suddenly, if any one goes down, if any system or any slave goes down, right, your data is lost. So how do this, what is that? Spark. It has got powerful fault tolerant model. It can recompute and get it right. So that fault tolerance model, separate discussion we have got, but it has got powerful fault tolerant model. And one more important feature of this PySpark, right? Persistence. Persistence. No need to again and again do the same execution. No need to perform the same things, right? Operations again and again. Right, no need to perform the same operations again and again. So we have got persistence means if they are persistent means available in the RAM. It will be available in the RAM, right? So it can provide its output to the next flows. Yes, it provides output to the other flows. So if I say about persistence feature, means whenever you perform any transformations, right? Transformations, a particular transformation used by multiple flows. See, this a Spark is a data flow language. It's a data flow language, right? Yes. So here, data flow. But from here, the flow is going in this way. So here, if the flow is going in this way, right? So this particular transformation used by flow 1, see this first flow, second and third. So these 3 flows are using this particular transformation. So persist this transformation, make this particular thing available in the RAM only so that it can provide its output to the other flows, right? Yes, persistence features, right? In-memory computations, lazy evaluated, fault tolerant, persistence, and distributed, and parallel processing, right? Yes, parallel processing. The main feature you can see is parallel processing, right? Within this. So real-time usage of PySpark. If you see coming to this, where exactly this PySpark used in the real-time scenario. Okay. Yes. Any query? So real-time usage of PySpark. In commercial sector, right? So if you talk about it uses Apache Spark real-time processing systems. Banks, if you talk about the bank and other financial fields, using Spark to retrieve the customer's social media profile and analyze to gain useful insights, right? Which can help them to take right decisions. Bank and other financial fields using Spark for retrieving the customer's social media profiles, right? The extracted information is used, right, to just again analyze about the credit risk assessment, targeted ads, and for customer segmentation, right? So Spark, if you talk about this PySpark, right, it plays a vital role even in fraud detections and widely used in, especially mostly used in ML tasks, machine learning tasks. In healthcare also, right, even within the healthcare. In healthcare, right, it is used to analyze the patient's records along with the previous medical reports data, right, to identify which patient is probably to face this kind of issues, right, even after being discharged from that particular clinic. So using this to analyze the patient's patterns with his history, with his health history, right, just identifying or analyzing or predicting, right? Yes. Even if you talk about, okay, in healthcare, right, one second. And today, if you see, even in the entertainment industry also, it is mostly used. In entertainment industry also, it's one of the largest sector, right? Entertainment industry also, it's one of the largest sector which is growing towards online streaming, right? Online streaming. So the popular online, if you see the OTT platform, the famous OTT platform, Netflix uses Apache Spark for real-time processing. So to personalize the online movies or web series. So it, if you talk about it process approximately like 450 billion events per day, right? That are streamed on server-side applications, right? Okay, even this, I mean to say that Netflix also using Apache Spark today for this. And even in the e-commerce side, right? E-commerce side, leading e-commerce websites like if you talk Flipkart, Amazon, etc. All this, they are using Spark for advertising. Even like there are some other sites like Alibaba provides enhanced customer experience and optimizes the overall performance. Apart from this, like even in the tourism industry also, right? Yes. Spark is used here to provide advice to millions of travelers by comparing hundreds of tourism websites. So these are the major things, right? Yes. So even if you talk like why we need to go for Apache Spark as come. So even we have got big data, Hadoop is available, right? Yes. If you talk, observe here, if you talk like PySpark, right? Yes. See, observe this one. I'll come back to it. So there was a test conducted previously by Yahoo, right? Yahoo has conducted a test to check the speed of various databases. So by taking a table of 100 TB size, yes, 100 TB size consisting of 1024 columns. Yes, the test or the task is sorting based on 16 columns. And time taken for the different databases. Talk like time taken by the different databases, right? So if you talk about Oracle has taken nearly 3.5 days to process. And if you talk like MySQL has taken nearly 6 days. And we have got some specialized databases like Teradata that's just taken 4.5 hours, right? 4.5 hours. And Netija has just taken 3 hours. Okay, fine. Finally, if you see, if big data Hadoop has just taken like 3 minutes, right? 3.4 minutes, 3.4 minutes. So where is this 3 hours or 3 days or 3.5 days, right? And Hadoop has just taken 3.4 minutes. But if you talk about this PySpark, right? PySpark, right? It's 100 times faster than Hadoop. 100 times faster than Hadoop. Then you see the speed of this Spark, right? Hundred times faster means see the speed today, like Spark, very high speed processing because of this in-memory computation, data storing within the memory, data getting processed within the memory, right? Because of which we see very huge. So we are going to see, we are going to build, it's a data flow, right? As I said, so we are going to perform some, we are going to trigger some action, then only it's going to get executed. It's going to divide into partitions, distributed across multiple machines, processed parallelly and giving the result, right? So it's 100 times faster than this. So this is what the motivation towards Spark, right? Yes. So even if you see like the PySpark job market, you can just check this PySpark jobs. You can just Google and check. Even you have got a lot of demand for it, and even see the salary packages for PySpark as compared with other technologies, right? The package will be very huge as compared to other things, right? So if you see what I'm going to discuss as part of this course, right? When we have got a lot of things I'll be discussing, or each and every functionality of PySpark in brief, in depth, right? Starting with PySpark introduction, we have this especially for Spark with Python, especially it has got many functions it is providing, right? Especially for Spark with Python, it has got many functions where we don't need to write huge coding. The main advantage of using Python for implementing Spark, Python has got its own advantages, right? Very less code you see, simple syntaxes we see, right? For this, and many modules, wide varieties of modules you can see, right? Many modules are available for it, and we can interactive, we can easily go for interactive mode. And here you see why Spark need for PySpark, and PySpark sessions, PySpark context, Spark context, right? And PySpark RTD, parallelizing, repartitioning, broadcast variables, accumulators, and PySpark computations, RTD computations, uh, RTD persistence features, different persist options, memory and disk options, core computations like fault tolerance model, creation of partitions, groupings and aggregations, and difference between those different types of groupings and aggregations, and various actions and transformations one by one in brief, right? Like no need to write any code, directly we can apply these things: count by key value, sort by key, union, distinct, joins, co-group, Cartesians, other. And if you see the major advantage we see in PySpark is the data frames. PySpark SQL, most see in PySpark mostly used ones like data frames. Previously RTDs were used a lot, but now data frames are used a lot, right? And making the data structured and using map and multiple expressions. And if you see like SQL context, data frames API, various data frame APIs, and PySpark data frame creation, empty data frame, converting data frame to pandas, and show, PySpark show, row class, column class, select, collect, with column renamed, where, drop, order by, sort, group by, John, union all, right? Many UDFs available, map, flat map for each sample, pivot, partitioned by, yes, all this. And apart from this, if you go to the PySpark SQL functions, lot of SQL functions like aggregate functions, window functions, data and timestamp functions, JSON functions. And if you talk PySpark built-in functions, well, so we have got lot of functions, each and every function with some examples, right? Yes. String, translate, overlay, to date, difference, month, explode, yes, map keys, map values, struct, row, rank, dense rank, percentage, percent rank, type from JS1 to JS1 tuple, PySpark external sources, how to create these things from external, from Hive, MySQL, narrow and wide transformation, addition of new columns, dropping columns, renaming, handling nulls, window functions. Yes, and deploying PySpark applications, states and tasks, drivers and executors, building Spark applications pipeline, deploying Spark applications to cluster and tuning and performance tuning, and PySpark streaming concepts, integration with Kafka, and PySpark machine learning library. Everything will be discussed, right? In brief. Okay, it's a 10 weekends. It's so everything, it's a huge syllabus. We are going to discuss, right? Many functionalities of PySpark one by one in brief, right? So we don't need to write huge codings here. So it's a 10 weekend batch, like 2 to 2.5 months. We are going to complete it within 2.5 months, right? So yes, yeah, every session is video recorded. You will be getting the recorded video of it. Clear notes you will be getting session wise, topic wise, right? Yes. So even the software will be provided to you. So it will be provided to your Google Drive, yes, and notes to your mail IDs, and also videos to your Google Drives, right? Yes. Any queries from your side, anyone, right? Yes.
Daily, how many hours of session?
Yes. Akshit, right? So once again I say, right, it's Spark is a execution model, and Python is a language. PySpark is not a language. Python is a language. Spark is an execution model. Both the execution model for implementing or to code, you require a language. So we use. So for example, if you talk machine learning is there. To implement machine learning, we have got many ML techniques are there. Regression techniques, classification, clustering, recommendation, pattern matching, many techniques. To implement those techniques, right, we require a language. So Python is the mostly used in implementing machine learning or data science. Even in big data, like in Spark execution model for processing, for Spark processing, right, we require a language. Coding is done in Python. Yes, real-time processing, right? Yes, Spark is meant for real-time processing, right? Yes, Gaurav. So the rate at which the events are generated at the same rate, the events need to be processed, right? So we require such a kind of technology. So where you should have high speed, the rate of speed of generating of the events should match the rate of processing of the event. So Spark is such a kind of technology, right? Lightning fast technology, which at what rate the events are generated, at the same rate the events will be processed. At one side the events are generated, the other side Spark will be processing the events the same speed, so it can match the speed, right? Yes. So it's for data engineering role, right? Yes, Akshit. So, but don't forget, every data scientist need to have the knowledge about this, right? Where you need to perform some kind of ETL kinds of operation. Yes. So, okay, yes, daily, see, it's not like a daily base, it's a weekend batch, right? It's a weekend batch. So it will be on Saturday and Sundays. Saturday 2 hours, Sunday 2 hours, 4 hours, but later I'll be increasing to 2.5 hours, 2.5 hours. So 5 hours will be getting per week. So if you go for regularly Monday to Friday, you will be 5 hours, but also Saturday 2.5 hours, Sunday also 2.5 hours, right? Yes, it is also meant for batch processing. Spark is meant for batch processing. It's not for online processing, right? It's not for a single or 2 records or 3 records. We no need to go for Spark. So for millions and trillions of records, right? For millions and trillions of records, you go for Spark. For one transactions or 2 transactions, no need to go for this. Millions and trillions of transactions, we go for this, right? Yes, it's for batch processing, right? So here one thing, yes, if you bigger data sets will be taken, right? But not based on the data sets that you are going to process. You are just based on the schema and how we can process it, right? So if you got whatever it is, 5 records or 5 lakh records, the coding is not going to change. If you got 5 records or 5 million records, your coding remains the same, right? Yes, most of the things mostly we go for mostly in Spark, right? Data frames mostly used. Data frames are mostly used, right? Making the data structure, right? Okay, Python is mandatory to know for this course, right? Okay, so even if it doesn't have knowledge on Python, right? Yes, just I'll be briefing you about, right, for some one session or two sessions I'll be spending on this Python before I'll just give a brush up on all this Python. Python is not a kind of technology where you can learn, you can just update by yourself also. Simple syntaxes, very easy to learn, right? Yes, I'll just, before I go with the practical part, I'll just brief you about those things, right? Yes, structured, unstructured, right? So semi-structured, so taking some kind of other data, right? Data, some weblog data, URL data, JSON data, XML data, right? This kind of data also I'll be working with. Yes. Yes, roles and responsibilities, other things, right? And resume building, other things, every at the end of this course, right? I'll clearly provide all those things, right? Roles, responsibilities, and resume building, other things, right? Yes, how you can apply, and some sample resumes I'll be forwarding you. Yes.
Maybe do we need to complete Hadoop and Spark and Scala course before starting this? Not required.
So here, okay, just basics of HDFS required, basics of HDFS. HDFS commands knowledge is required. No, if other things even are not that much, but even the things, the basics, whatever required for this PySpark related to Hadoop, right? If not possible, I'll just provide you that basic videos of this. You can just go through of those things. If anyone doesn't have knowledge of the basics, right? So not a problem. Only HDFS knowledge, some is required, and some scoop knowledge is required. Means how to pull the data, from databases to HDFS, right? That knowledge is required. So if it doesn't have knowledge, I'll just provide that basic videos of this Hadoop, right? HDFS, not all the videos, like the HDFS and scoop, basic videos of it. So,
because currently we are in evening batch Hadoop. So currently we are having Hive.
yes, I can. The basics of HDFS required. So not it's not 1 day or 2 days. Yes.
Okay. Yeah.
So yes, Manjunath, right? Yes. At the last, I'll be discussing those kind, right? At the end of this course, I'll also give you the knowledge on those things. So in here, mostly we work with, yes, lambda expressions, lambda things, right? Triggering this lambdas, right? Yes. Yes, Kiran Mai. Yeah, even about in this cloud side also, how it is used and how we are going to use it also. I'll be providing you that knowledge on those things, right? And even you can see PySpark total functionalities, the various APIs of this, right? PySpark, everything in brief, one by one, we'll be discussing with multiple examples, right? So that's the way I'm saying it's 10 weekends. It's not like 6 or 8 weekends, right? It's 10 weekends. We'll be spending more time on this in brief knowledge. You'll be getting the command on this. Even for streaming, even sometimes I'll be at the end, I will be also showing some kind of streaming data, how to work with streaming data. Means data which keeps on incrementing, the data which keeps on generating such kind of data using this Flume and Kafka, right? Like how we can integrate, like Spark and Kafka integrate some integrations, like Spark Kafka integrations, Spark Hive integrations, Spark database integrations, like Spark NoSQL, like NoSQL database integrations also I'll be showing during this course. Yes, Panindra, yes. So yes, I'll be showing you how to run this, right? Even on this each weekend how many hours, right? So Saturday 2.5 hours, Sunday also like 2.5 hours, right? So like you'll be getting 2 hours on Saturday, 2 hours on Sunday, 4 hours or later I'll be when I'll go with the practical part, or later in working with Spark SQL. If not required, I'll be increasing to 2.5 hours, right? Yes. Yes. So the timing of this will be like 4:30 to 6:30, right? Yes, 4:30 to 6:30. Saturday 4:30 to 6:30, Sunday 4:30 to 6:30 is this batch timing. So tomorrow also you can attend the session, right? Everyone, you can attend the session to see more on this, right? So just today was introductory session, what we are going to discuss and what is tomorrow we'll be discussing in brief more on this. Tomorrow it's not like any duplication of today's, but we'll be continuing from here on to see more on this, right? Yeah. Any more queries, right? Any more queries from your side, anyone? So basic knowledge of Python required, but still I'll be providing that for 2 sessions. Just I'll be briefing you about all this Python functionalities, right? Yes. Yes. At the end, I'll also just show you like how to get this Spark and Kafka integrations, right? Yes. Okay.
Sir, good evening, sir. Hive and Spark with Scala, these are all knowledge mandatory, sir.
So the Hive is okay. So Hive HQL is similar to SQL only, right? Even that some basic means how to create it, how to that knowledge. If you're not aware, right? So like basics of from Hadoop, what you can take is basic HDFS, basic scoop, and basic Hive knowledge required, right?
But
So
we don't know that when we are providing any classes.
yes, I'll provide some videos. It's not a, it looks like normal SQL only, right? HQL also similar to, HQL is similar to SQL only, right?
Yes, sir.
So how to work with those things before I go with the integration part? Either I'll ask you to go to the video and come. If you have got any queries, you can ask me up there. Before I start with those kind of topics, that I'll just, if any prerequisites are there, I'll just provide that step-by-step explanation is provided in that videos, right? So just not all those, some videos, right? Basic videos. Yes, definitely. I was saying, right? You'll be getting great command after this course, right? With all these functionalities, right? RTDs concept, data frame concept, DS streams concept. Right? Yes.
Any cloud knowledge mandatory, no, sir?
Yes. So I'll say I'll also provide you those things, right? At the end.
Okay.
Yes, even for this. Yes, it is helpful for designing Azure Databricks also, right? For notebooks. So here I'll be showing you in this Jupyter, I'll be different environments I'm going to show you, right? In this Jupyter notebook and Spider ID. There's some IDs I'll be using like Spider ID, PyCharm ID, Jupyter notebook. Yes, and Google Colab, right? And within this VMware also, I'm going to provide these things, PySpark running on this, where I'll be giving you that VMware where you can see all these components, Spark, PySpark, Spark with Scala, and other all the Hadoop components you can see, right? You can work with it. And okay. So fine. So if I'm done with the queries, then I will sign off for now. Meet you tomorrow, right? Same time at 4:30 to see more discussion on this, right? Yes.
Once you show me that notepad, sir.
Which one?
Notepad, sir.
Yes. 1 second. These things I'll be forwarding you, right? No, notes, whatever it's. Okay.
Sir, basic Python is enough, no, sir. Actually, I'm your batch 9 o'clock student, sir. Actually.
Yes. Basic Python is enough. No, okay. No need of total advanced Python. All those concepts not required. Basic Python knowledge, and mostly like you need to have the knowledge of functions, right? So by the time we go deep into this PySpark, okay, you will be completing those things, right? So basic Python is enough. That's enough, right? So for the first 2 weeks, right, we'll be discussing more on these environments, installations, modes, and RTDs, those things, right? How they are computed, how they are created, those things, right? Yes. Fine.
Sir, one question. What if I miss one or two classes in between? Because it may happen.
So yeah, not a problem, right? Yes. So it's a weekend batch. We might be having multiple. So you'll be getting time only on the weekend. So many people can miss the session. In such case, you'll be getting the recorded video that day itself, right? At 6:30, for example, 6:30, the class gets completed. By evening 8:30 or 9 o'clock, you'll be getting the recorded video session, right? It's only viewable. It's not downloadable. You can just view it. So if anybody on Saturday, if they're absent for Sunday session, you can be ready with going to the video, right? So every day means every session is recorded. Every session will be recorded. You'll be getting the recorded videos of it. Even if you're absent because of some job timings, if you're unable to attend, or because of some ill health, or because of anything, you can just go to the video. Still, if you got any queries at the next session, at the end of the session, you can spend time for your queries. Yes.
Signing, and you will use Azure platform or AWS or Google?
Pardon? So just I am going to show you this cluster on this cluster, right? How we are going to execute these things.
Are you providing interview questions?
Yes. Many interview questions at the end. Some sample resumes, interview questions I'll be providing at the end, right? Yes.
Sample resumes in the sense you are providing as per big data.
Yes.
Resume, right?
Yes, big data environment.
Okay. Actually, I'm looking for Azure environment. I mean Azure data environment.
Yeah, big data environment only. Just my resumes will be from big data environments, right? Yes. Fine, right? Okay. So I'm stopping here. We'll continue tomorrow. Same timing at 4:30. You can follow the same link to see more on this, right? Yes. Right. Thank you all for your time. Thank you. Yes.
So tomorrow also same time?
Yeah, same time you can follow, same time, same link, right?
Okay, sir. Thank you, sir.
Yeah. Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right?
Yes, sir.
Fine, thank you. So in the last yesterday session, right, just I was briefing you about what is PYSPARK, why PYSPARK, right? So yes. So what is Apache Spark for big data analysis for processing and computation, right? If you see more on this, Spark was developed, the personality who developed, right? Spark was developed by Matei Zaharia, right? In AMP lab. It was open sourced. Spark was open sourced, right? In the year 2010, Spark was open sourced. In the year 2010. It was donated to Apache Software Foundation, right? It was donated to, yes. It was donated to Apache Software Foundation. In the year 2013, right? In the year 2013. So it was developed, it was open sourced in the year 2010, and it was donated to Apache Software Foundation in the year 2010. used for big data analysis and processing and computation, right? Used for big data analysis, processing and computation. Why PySpark? As I was discussing, like why PySpark. So before that, why PySpark, right? Why PySpark? Yes. Yes. I defining Spark, right? If I want to define Spark, defining Spark. Yes, I define Spark in 4 lines, right? So 4 to 5 lines. Yes. Spark is a open sourced. Yes. Sorry, there was a connection problem, right? Fine. Now is my voice clear and audible to all, right? Yeah, can everyone please confirm once again, is my voice clear? Fine. So Spark, I define Spark in 4. Yeah, it's an open source distributed execution framework, right? Distributed execution framework cluster computed in-memory computation with parallel process style. With parallel process style. For large scale data processing. For large scale data processing, right? Yes. So here Spark is an open source distributed execution framework cluster computed with in-memory computation feature and with process style, parallel process style for large scale data processing. Large scale data processing, right? Yes. Okay. So Spark can be coded with different languages. Spark can be coded with Scala by default. Actually, Scala by default. But as compared to Scala, right, today like Python has got many libraries, many built-in libraries, right? Even for, especially for graph algorithms, machine learning, these techniques, right? And for recursive algorithms. So that's why Python also mostly used, both the Python and Scala are mostly used, right? Right. And Java also can be used. So multi-language support. Spark is a multi-language support. It can be coded with Scala, Python, Java, and R language. Like R language also, right? Yes. Spark can be coded with Scala, Python, Java, and R language. And if you say why PySpark, right? Yes. It is the Python API, right? It's a Python API to use Spark. So why PySpark means PySpark is the Python API to use Spark. Sorry. So what is PySpark? Is a lightning fast technology. It's a lightning fast technology. Yeah, that is designed right for fast computing. Designed for fast computing, right? Yes. Is the lightning fast technology that is designed for fast computations, right? I can say like PySpark is a demanding tool. It is a demanding tool among the data engineers, right? Among the data engineers to work with bigger data sets. Okay.
Sir, will you share this notepad with us?
Yes, that's why I'm preparing notes parallelly, right? So no, okay, this everything I'll be forwarding. PySpark is the Python API to use Spark. It's a lightning fast technology that is designed for fast computing. It's a demanding tool among the data engineers to work with bigger data sets. So next, okay, PySpark used for what? So PySpark used for, yes, distributed SQL, creating data pipelines, ingesting data into database, running ML algorithms, graph data streams, right? Yes. So yes. So using we can also write a data into data. I can create a database table. So from a data frame. So Spark data frame is there. The Spark data frame I can write into a database. So a table gets created. I can read the data from database directly. Spark can read data from database directly without the use of any scoop like. And directly Spark can write into the database. And Spark can integrate with any databases like Spark can integrate with Hive, Spark can integrate with database like MySQL or any other, and Spark can integrate with Hive and NoSQL databases. Creating data, I said Spark is a data flow language, right? So collection of pipes. At each pipe, either transformation, filterings, groupings, aggregations, or sorting you are going to see, right? Yes. So if you see the various, okay, we have got some PySpark mini packages available, right? Yes, as compared with the Scala, right? PySpark packages. Just PySpark itself is a package, and within that we see like sub package PySpark.sql for SQL operations, for data frame creations, many SQL functions it supports, right? And even PySpark is supporting many modules, right? Many modules and functionalities, even for streaming, right? Even for streaming, if you see like a Spark streaming, micro batching, right? Quick results. I want quick results, right? For every 2 seconds, I want some updates. For every 5 seconds, I want updates, right? Yes, and also not only for that, even like Python is mostly chosen, right? Where Python itself has got many modules. Right? For machine learning, like if you see like Pandas, Matplotlib, NumPy, Pond, CP, Scikit-learn, but still PySpark has got, right, PySpark.ml. That's got many modules and functionalities, right? And even PySpark.mllib, right? Yes. Okay. So if you say like Spark plus Python, so Spark is once again I'm saying Spark is an execution model plus implemented by using a language called Python. Spark and Python combined is a like PySpark. Execution model implemented by using a language called Python. Not only multi-language support. So generally, yes, we have got HDFS. So generally, okay, just I'll show you this, right? So this is your HDFS, we say. Hadoop distributed file system. We say like big data Hadoop, right? Hadoop has got HDFS. So Hadoop is meant for two things: storage and processing. Storage and processing, right? Yes. For storage, it doesn't use any database, right? Because databases has got some drawbacks. Databases has got some drawbacks. Means limited storage databases. Most of the databases, no parallel processing. If volume keeps on increasing, right? Means if you see, if you want the total amount to be calculated for 10 records or 1,000 records or 10 lakh or 1 crore, if data volume increasing, speed decreases, right? And mostly like we talk about the databases can handle only structured data. So despite of all this, it's not going with the databases for storing its data. It's going with a file system called Hadoop distributed file system. Hadoop is meant for two things: storage and processing. For storage, we go for HDFS, not any database, because I was just saying like you have got some drawbacks with it. So despite of this drawback, still Hadoop doesn't goes with database. It's going with a file system called Hadoop distributed file system. And also for processing, Hadoop used to use MapReduce. MapReduce was widely used. If you see from, if you go back like in the year 2012, 13, 14, 15, 16, right? MapReduce was widely used, but now MapReduce is got outdated because of this huge codings and many lot of programming required for this. So it was, so we are using Spark. So for storage and processing, and for storage HDFS, and for processing, now we are going with Spark execution model, right? We are going with Spark execution model. Spark has got very high speed, right? Spark has got very high speed processing. So computation, right? Storage happening within the memory and processing also within the memory, because of which we are going to get huge, very high speed. So Spark, again, implementation. Spark has got implementation using coding, coded with multiple languages. I was saying like Python, Scala, Java, and R language. So, but Java is never preferred. Only some less companies like only some companies, only like couple of 1 or 2 companies, right? They'll be preferring for Java, but our language is never used. Okay. Python and Scala is mostly used. By default, Spark built by using Scala, right? So Java means, I was saying some companies like Value Labs, or a couple of companies, 1 or 2 companies only using Java, Spark with Java implementation. We see like huge codings here, but Scala mostly preferred, Python mostly preferred. But nowadays Python is mostly used, right? That's got for, especially for ML, for ML techniques, ML algorithms for implementations, right? Where PySpark providing many built-in functionalities. Even Python itself has got many modules, right? So total, if you talk about ML, machine learning or data science, total implementation goes in Python, right? Yes. So from different databases, OLTP, online transactional processing, think database, database 1, database 2, database 3, think branch 1, branch 2, branch 3, 3 databases. From this, you are going to pull the data. You are going to pull the data from these different data sources, different OLTPs, online transactional processing. Generally, how to pull the data? You use a component called scoop import. Scoop import, right? Scoop import. Scoop is nothing but SQL plus Hadoop. Scoop import. Into HDFS, you are going to bring the data. You are going to bring the data from different sources to Hadoop. From Hadoop, from HDFS, right? You have many processing components. Previously, MapReduce, Pig, Hive, or they used to take. Now, from this HDFS, your Spark is going to read the data. Spark is going to read the data from this, read the file, and it is going to process it. Process. And again, after processing, again, it can store the data into HDFS. After the result again can be stored in HDFS. Again, from HDFS, you can move that result back to the databases, to the websites. So again, okay, your data is moved to the databases. Otherwise, even I was saying, right, Spark can directly, no need of, okay, Spark can directly read data from this database and write data to database. It can read, it can write directly without the use of scoop also. Without scoop also, directly Spark can read that entire table, and it reads the table. This is your database table. This is your database table, right? Table. This table, Spark reads and creates a data frame. It creates a data frame. Data frame is also a structured one, right? With rows and columns. Yes. Again, this data frame, if you want, it reads, Spark reads. And again, this data frame, if you want to write into database, you can write this data frame, you can write and save into the database table. So this both you can perform all this, right, using Spark. So Spark plus Python, Spark and Python combined, we say like PySpark. And I was just saying like Python and Scala, which are mostly preferred. What is the differences we see means? So Python is dynamic typed in the sense variables that what we are creating, variables x equal to 10, y equal to 4.5. Like C language, like Java, we no need to say int x float y. What value you are assigning? Integer. So integer variable creates. What value you are assigning to it? Float variable. Float variable getting created. Z equal to a list. 10, 20, 30. A list of values. What type of variable Z is? List type. How it is list? Because you are assigning a list to it. So based on that, what value you are assigning to this? Based on that, the variables created dynamically. It's dynamic typed. Scala is static typed. And we talk like Python has a huge community, right? It has got huge community. It is small community, is smaller. So we say like Python software foundation, Python software foundation, right? And Python contains powerful libraries, right? For machine learning, graph and iterative algorithms, less as compared with Python. And if you talk about the PySpark features, main PySpark features, right? In-memory computation, PySpark features in-memory computation. So within the memory level, we can just load and we can just process within the memory, right? That's why we call it as in-memory computation. And lazy evaluation, right? I was saying lazy evaluated is best suited for Spark, which is lazy evolution or active evolution, which is good. Lazy evolution. Lazy evolution means on required you are going to execute. When required only you will execute. Means on demand. By performing an action, we execute the entire flow. Spark is a data flow language. Spark is a data flow. So the entire data flow gets executed only when you trigger an action. Until then it won't execute. Just like a normal function. When you call the function only, it executes. If you're not making a call, when you make a call, at that point only it executes. Any number of times it can execute. Here also, we need to compulsory trigger an action to execute a Spark data flow. Fault tolerant. I said like Spark data objects are divided into multiple partitions stored across multiple RAMs of multiple slaves. If you talk about the Hadoop, it's stored within the disk level, right? But in Spark, what the data is storing means disk processing compared with memory, right? RAM processing has got very high speed, right? Fine. So already Hadoop has got very high speed as compared with the other technologies, right? Still, but Spark has got because of in-memory computation. But during the processing, as Spark processing happening on within the cluster level with multiple machines, right? The data is distributed across multiple machines and is processed parallelly. During this process, as they are machines, if any one slave goes down, right, then Spark has got powerful fault tolerant mechanism, right? It can rebuild. There won't be any data loss and there won't be any failure, job failure, right? So that I'll be discussing in brief about the fault tolerance, how Spark is able to rebuild the data and how it is recomputing, right? Yes. And persisting.
Sir, HDFS means storing the data at disk level.
HDFS, yes, HDFS, right? Hadoop distributed file system. See, every node in your cluster, see every node, okay, 1 second. So one more thing, Hadoop or Spark, what we discussed, right? So it is not for client server architecture. I'm coming to your query only. It is not a client server. It's not for clients. It is not for request response. It is not for request response. It's not for online applications. It is not for online processing. So first thing what you need to understand, Hadoop or Spark is not for online processing or online applications. See, there are two types of applications, online and batch applications. Online applications or batch applications. Online applications means user interactive applications. User interactive applications means user gives the input here. Until the here batch applications means user non-interactive. User non-interactive applications. User doesn't give any input here. These are the applications which runs in the background. So here where you see millions and trillions of data, where records, for example, right, millions and trillions of records. For example, generating credit card statements for millions of customers. Here user doesn't give any input. If you're making a single online transaction, right, you are going to give the input from source account to destination account compulsory. Without that, the online transaction, booking a movie ticket also, right, user interaction required. But here for batch applications, yes, user non-interactive, right? So if a mobile bill statement generation, credit card statements generation, for example, allocating a railway ticket means your waiting state is 200 or 150.